Well, hello everyone. Welcome to MOS at Home. My name is Megan and I will be your moderator tonight. Now, if you are joining us here on Zoom and you would like to see captions for this show, you can access those by clicking the CC button on your screen and selecting Show Subtitles. Now, today we have a great show for you today. We will be talking with scientists who are creating new American Sign Language terms to increase accessibility in the field of quantum science. Now, for folks who may be new to this, American Sign Language, or ASL, is the language that is used by many people in North America who are deaf or hard of hearing. And all of our guests today are deaf of hard of hearing or hard of hearing. So they will all be using ASL and ASL interpreters to talk with us. Now, right now, the interpreter on screen is translating what I say into ASL, and the interpreters will also translate ASL from our panelists to spoken English. Now, we'll meet our panelists in just a moment, but first, if you have any questions for our panelists, you can go ahead and enter those at any time by clicking the Q&A button on your screen, and we'll try to answer as many of those as possible just a little bit later in the show. Now, if you are joining us on Facebook or YouTube, unfortunately, we cannot see your questions or comments at this time, but we're thrilled that you're tuning in. All right, now let's get started. I would like to welcome our panelists to go ahead and turn on their cameras and introduce themselves.
Hi, everyone. Hello, hello. Hi, everyone. My name is Mandy Houghton. This is my sign name. I'm the lead for this project where we're working to create quantum science material in American Sign Language. So this work, we collaborate with Harvard University and the Learning Center for the Deaf, CEQUM. I've been involved with the center for quite some time now as an intern, doing some research. I also am a former high school science teacher. So really my journey through the field of science has led me to this today and this issue where we see a lack of quality sign in STEM fields. It's not easy for us to access this material in American Sign Language. And this really brought me to the question of why and how we can work to better that. For language to exist, for us to use it, it really needs our attention in this area. And so I work with a team of amazing deaf scientists, like you'll see Colin and David here today. And we do talk about this work in ASL. The Center for Integrated Quantum Materials, CEQUM, has been doing this important work for some time now, and I'm really hoping to continue doing this work and stay involved in quantum fields as we continue to see more innovations happen. So I'm excited to be with you today.
Hi, everyone. My name is Colin. I actually hail from Boston, and the Museum of Science was one place I really loved going to throughout my childhood. So it's really nice to be back, even virtually, just to chat with you. Now, I love physics ever since high school. I noticed physics is a great way for me to explore all of the variety of different interests that I have in one subject. And I'm thrilled to be involved in this project because here I can figure out how I can blend my interest with physics and how that can connect nicely with sign language. I work right now at the University of Illinois, Urbana-Champaign. I'm a PhD student there studying physics, and developing quantum science and scientific science for my field has really helped me in my education.
Hello, everyone. My name is David. I have a little bit of a funny story because when I went into college, I was a physics major. But after 1 year, I decided that I didn't want to be involved with physics. It was kind of a bad experience. And really, it was related to communication. After I graduated, I didn't really know what I wanted to do. So I decided to go back for a graduate education. I am doing that, and I still don't know what I want to do. So I decided to work short term at the admissions office at RT, and that's actually where I met Colin. and I was trying to recruit him to my college, but it didn't work. He decided to go out to another college. But during that time, as I was working as an admissions counselor, I realized that really I was passionate about liberal arts, but I missed science. So I decided to try for physics one more time. And I noticed, yes, this is the path for me. So as I went through my physics degree, I went into a graduate program at U of R for optics, and I love what I do now.
Wonderful. Thank you so much to all of our panelists. We're so excited to have you all here. Thank you very much for those introductions. Now, I do want to remind our audience that if you have questions for our panelists, please go ahead and type those into the Q&A at any time, and we will try to get to as many of those as possible a little later. But first, I have a few questions for our panelists to kind of get us started. And again, thank you so much for being here, all of you. So we talked a little bit about your work developing sign language for quantum physics, but I'd kind of like to just talk to you first about your work in the field of quantum physics. So can you tell us a little bit more about what it is that you study and what kind of excites you about the field of quantum physics?
I don't mind starting off. As I had mentioned in my intro, I've loved physics since high school. In my undergrad experience, I took a lot more courses for more in-depth physics and many different fields of physics. As you know, physics, or maybe you don't know that physics has quite a lot of fields within the subject. That's where I discovered quantum information science. And I really was drawn to it for two reasons. It discussed questions like, why are we here in this world? What is the universe made of? These fundamental questions. But it also mixed in ideas of how we could use what we learn from these foundations, how we can use quantum information science in order to solve difficult problems. So I decided to continue this exploration of quantum information sciences in my grad school, where I study light. If you can imagine a light bulb, what you're seeing is actually millions, billions of photons that are being emitted through the light. That's the smallest unit of light. Once you take one of these photons, you can analyze its properties and do a variety of different new applications with it that we could never have done before. And that is my research.
And my undergrad was kind of the same. I took many elective classes, and I took one called Physics and Optics. The professor was really cool. He had a lot of contacts out in the community here in Rochester, New York, that is. And on one class trip, we went to the lab for laser energetics. We abbreviate that to LLE at U of R. And as I was looking around, I just thought, wow, this is so cool. You know, who doesn't love lasers? They are really, really cool things. And that lab, they have some of the largest lasers. You know, huge mirrors, huge pieces of glass. So as I was chatting with people who worked there, they all were telling the same story of how they loved going to work every day. And I was like, wow, I want that feeling of excitement at work every day. So that's really where I started to get into optics. And now I study super oscillation. And really, if you have a picture and you're trying to get more and more, you have one picture and you're trying to get more and more information out of that image.
Yeah, I can go next. So really my involvement in quantum science, I would say quantum science found me, oddly enough. I have a background in biology and my science journey is pretty interesting. So I started actually wanting to study midwifery and then I realized that wasn't for me and I looked into neonatal nursing. Again, didn't really feel right for me. And then I decided to teach biology. So I pursued a career in education, applied for an internship though later on in college. The internship accepted me and it was related to quantum science. And that was really the beginning of my journey in the quantum field and really the quantum world. And so, why I do this work really a bit of a backstory for you. When I joined Gallaudet University as a student, this was the first time I had a deaf science teacher, the first time in my entire life. I'd never had a deaf teacher who taught my science classes, and they were incredibly clear, and it was so captivating. The way they explained science concepts was fascinating to me. I wanted to be able to do that, and so it really helped me to make the decision to minor in linguistics. So I loved the idea of learning about how to sign these concepts in ASL. So my minor in linguistics, then a little bit down the road, I realized, wow, this language that we have in ASL, it doesn't exist when it comes to STEM topics for the most part. And so this led me in my journey to be more curious about this, more curious about science and how we discuss this in our own language. So here we are today, and now I am working closely with a team of scientists to really investigate just this. So quantum material and how we can articulate this in American Sign Language.
All right, good. Thank you so much for that. That's so fascinating. It's wonderful to hear about the incredible science that you're all working on. I know that quantum physics is really like such an up and coming field, and is likely going to be such a big part of our future. So I really appreciate all the work that you're doing in the field and also to make the field more accessible too. That's great. So my next question is, so what was it like for you as physicists to learn to communicate physics related topics before you joined this project, creating new ASL terms for quantum physics? And then what was it like sort of after more of these signs were available? Did anything change for you at all?
Yeah. During my journey, arriving at where I am now, I was a physics tutor. And that was really the point where I was like, why, signs and science is so important, because oftentimes we're trying to communicate specific information with a specific meaning. And I just noticed that I couldn't do that very well. And the students have to translate to English themselves and try and figure out the English meaning and the way that we can best sign that. But I figured putting that work on the student wasn't the greatest thing. So working with these great people to develop the new signs, and as we've done that, and I apply that to my work as a physics tutor, I noticed that it did make a big difference. Some students who weren't understanding the new signs, that was fine. I would explain it because at the same time I was a tutor, so really you want to try and explain the concept as clearly as possible for that student to understand. So I was doing that at the same time as teaching new signs and saying like, this is what this means. So then after that, communicating those concepts became much easier. And then our understanding of the concepts began to scaffold, and it was a lot easier because we had that foundation to talk about deeper concepts.
Yeah, I completely agree with you, David. I can definitely relate to your comments, especially as a student, both as an undergrad and grad student, and as to where I am right now as a PhD candidate. I've been thinking about who my language models are, specifically in the STEM fields. I can read things in books, I can go to classes and understand the topics with the help of interpreters, but if I want to kind of express my ideas, I have no one in my peer group who I can kind of brainstorm with. All the people out there who are talented or who are recognized as being talented don't necessarily know ASL. So as a scientist, when these new signs were developed, these new tools were developed, I realized how much that helped me communicate better, think even through problems better, and express myself in a different way. My research became a lot more clear. My analysis became a lot more clear because I could actually discuss with coworkers in a way that I couldn't before, these concepts, and express myself in a way that I couldn't before. All of these famous scientists that we read about, Einstein and Newton, they actually had the same challenges back in their time. they found out new physics topics or new physics phenomenon, and they didn't know how to explain it or label it. So they had to come up with these words and terminologies from scratch. So I feel like I'm in a similar boat with them, working with developing ASL science for all of these concepts. Now, I mean, I believe that our work, our findings will impact the same way that Newton and Einstein was able to impact their fields individually.
Yeah, and I did want to add to Colin's comment. As a student, I agree fully. When I was starting my graduate studies, signs were really not developed yet. It was really kind of a struggle to understand what the teacher was communicating with me. But later, as we developed these new signs to match different physics concepts, it became so much easier, like he said. And two of my favorite experiences I can remember with Colin, actually. One was when we were in undergraduate. Colin had the opportunity to visit my college and visit the lab that we were working in. And so I was explaining, everything in the lab, and Colin was asking so many questions like, oh, what does this mean? Does this mean you do that? And I would say, yeah. And for the first time, I noticed that I could express myself in what we were doing in ASL. And then we noticed that that was different trying to communicate with a hearing person compared with another ASL user, another deaf person. So that was really a unique experience for me. And then also, it's funny how sometimes we can, have an approach for one word. For example, degenerate. In general, it means that you have the same energy levels, the same amount of something, but often the interpreter or other people will see that word degenerate and think that means to degrade or like to degenerate, like a degenerate person. So it's a missed sign. So trying to learn the words myself, I was like, like lousy? Is that what it means? That doesn't match what I read in my book. So I would clarify with the interpreter, but it would have a different meaning. And then Colin was having the same exact experience as me, and he shared that with me. So it was really interesting to see how the struggles were kind of the same between us scientists.
It's really amazing to see how much this work has an impact on a variety of different levels in science for students and their learning of this new information, and then even the way we communicate as scientists, even with other people, even with interpreters as we communicate with our colleagues. So myself participating in society, friends, family, these discussions, it really impacts every level of our life. The language that we've developed over all of this time has created space for these conversations to happen instantaneously, organically, and without these times where you need to clarify and there's miscommunication. This is something I never saw growing up. It's new. And there are many deaf people out there who do not have this similar experience, don't have this space to talk about this type of content in their native language. They're often isolated in their fields, not working with other deaf scientists. So I think it's important we recognize that gap, and we see our team, especially Colin and David, now having this opportunity to have scientific dialogue in ASL and see, wow, that sign actually is really misleading, and start to have these conversations. This happens all the time now. It's very inspiring to me, and I want to see this work continue because often, I see them doing their work and it makes me wish that I could get back into the classroom and I could teach, because when I was teaching high school science, I didn't have these tools that we're developing now. I didn't have the language at the ready. I was trying to explain these concepts without relying on finger spelling, which is really just a way of using English to clarify a term that doesn't exist in ASL. And it's a huge challenge. I could see my students wanting to learn, but really having a lot of barriers when it came to access. So this work and other work that's happening out there, it's important that we see more deaf scientists involved, more deaf people involved in STEM fields. It's becoming easier to talk about this work, and it's making me want to go back and be with those students again, but I'm very excited to continue this work.
Great. Well, thank you so much for all of that. That was great. And so It's so interesting to hear about this work and how much of an impact that it's had on you all and the teaching that you do and your research. And we have a few questions coming in from the audience. So I would love to get to a couple of those, and then we can continue the conversation. So we have a question coming in. How do new signs start? And if multiple people come up with different new signs for the same term, how does the community decide which one becomes mainstream?
I can take the, oh, unless you'd
I
like to,
think
David, go ahead.
I think Mandy's the best person to take this.
Sure, I can start. So really this happens by starting to look into what are we talking about? So what is the concept that we're discussing right now? And then it leads to a discussion about if the information exists in ASL. So we'll talk about the sign. We'll figure out if it exists, is it conceptually accurate? Does it convey the same meaning? Yes, no. If no, why? Do we only rely on finger spelled words? Is the sign, kind of a hack and it's not really conceptually accurate? So we look into what we already have at our disposal in American Sign Language, and we build off of that. We build off of root signs and root concepts. We build off of something like this, for example, could come from another country's signed language. We might see similar signs that we could adjust to follow the rules and parameters of ASL. So maybe it means adjusting a movement or adjusting a hand shape, something that feels natural in ASL. We don't want to just do something random that out of the blue doesn't make sense in our language. We do have to follow the grammatical rules of ASL, but it might be inspired by another language's sign. And then we use it in conversation and we figure out, how does this make sense? And then we target that word, we continue to work through it, and then if we feel like it's the best model for that specific concept in ASL, we share that word, that new term, with our community. And it's decided by the people who use it. So language goes out to the people, and the community of deaf scientists using this are going to be the ones to decide whether or not it makes sense. If the community does not take a liking to that sign, then it means we need to reevaluate this and revisit what that sign looks like and how it's used. And maybe it means the production is a little off and we have to adjust a hand shape. Or maybe there's people in our community who can provide us some insight on how we need to make some of those modifications.
Yeah, I would love to add to Mandy your comments. So this discussion, this brainstorming is, I think, the most fun part of our work, where we can kind of mix our interests for, ASL and sign language and science knowledge concepts that are in our individual fields. We can explore the nuances of what things actually mean, what things, when you sign them, what they imply. An example is that I often think of as electron. Atoms, they have negative particles that circulate within the atom. And often this is the sign that we see in ASL, the electron circling a closed fist. Now, at the same time, that applies that electron is something that needs to have a nucleus nearby it. An electron can't be separated from a nucleus, but science has proven that we actually can. We can take apart this electron and play with it and use it and innovate with it. So that often leads to the misunderstanding of younger deaf students. But if we come up with something where we're just using the finger, we realize we can still imply that an electron is both something within a nucleus or within an atom and something that can be taken outside of an atom.
And yeah, I also think at the end of the day, is it easy to use that sign? Does it do its job? If yes and yes, then I would assume people will prefer to use that sign. For example, when I was tutoring, I did have some students who were coming to me from different places, different countries, and they had a sign that they had learned in their classroom in high school, or some signs that they learned at the university themselves. So I would be signing a new sign, or they would, and we would kind of look at each other like, what does that mean? And then the student could start a conversation like, oh, why am I using this sign? Do I prefer to use that sign? Or should I adopt a new one? And that's kind of how language develops. That's how it develops organically anyway.
Sorry, I didn't quite unmute myself there. So thank you so much for those answers. And we have another question here from our audience that you referenced a little bit in your conversation, but are there other disciplines of science that you have sort of a core team like yourselves working on quantum science? Do you have other disciplines like Mandy, you mentioned you used to work in biology. What are some of the other fields that you're developing signs for, or are other teams developing signs for right now?
Yeah, I can speak to that one, at least part of it, and the two of you can chime in about some of the other work. But the answer is yes, we absolutely have other groups focusing on other areas of science, doing very similar work. So, really, this work heavily relies on funding, which means that the project can continue if we have appropriate funding in place. And there's been several projects over the years, one focusing on STEM topics, for example, biology, predominantly in the K-12 setting. So yes, a variety of different areas, disciplines out there. And if you're interested in looking into some of the resources, I can share a few. One is ASL Core, one is ASL Clear. Another one that you could look into, really a variety of different social media pages, for example. Atomic Hands is one that comes to mind. So there's a few resources out there that are developed by deaf and hard of hearing STEM scientists, so those working in engineering, those working in science fields. And it's really where the language is coming from. It's coming from our work as it gets spread out into the community. So those are just a few resources if you're interested to learn more, you can take a look at.
I've been involved in several organizations who have been trying to develop signs. ASL Clear, like you said, ASL Core. And often I'll be recruited because I am a physicist. But at the same time, they do try to recruit other deaf people in their expertises. And I've seen some great and really cool things in literature, philosophy, biology, chemistry as well. And I did have the opportunity to watch some deaf people working on their chemistry signs, trying to figure out how to sign chemical reactions and, all of that. And I was joking, saying, you guys look like you're throwing up gang signs because honestly, I am lousy at chemistry. But still, it was fascinating to me because when they were communicating with each other, they understood exactly what they were meant and exactly what they expressed. But as an outsider, it kind of went over my head. So I kind of imagine that that's what people see when they see physics signs as well.
Just want to add a brief comment. I know in the past 5 to 10 years, it's been a really exciting time for this field because the number of deaf and hard of hearing scientists, people in the STEM fields, theorists, experimentalists, the number of deaf and hard of hearing people in these fields have exploded. And so it's great. We have a lot of different partners and collaborators that we can work with in order to kind of brainstorm and come up with, signs that everyone can agree upon. We share ideas not only about sign language, but from individual topics. And we even use that for our own research, or, I, from a physics field, will lend a concept to another person in a different field. It's just an exciting process as a community to be able to be involved in this kind of collaborative work.
Wonderful. Thank you so much for that. And you've actually, in all of your answers, you've answered more of the questions that we've had up here. So thank you for that. We're almost out of time, but I want to make sure that we get to just one more question that I have for you before we close out, which is, what's some advice that you would have for either students who are maybe interested in pursuing a career in physics, or maybe students who might be doubting a path in STEM because of some kind of accessibility barrier?
I can start. Well, from my experience as a STEM student, I think the most important thing is finding those allies, finding friends, teachers, mentors, anyone in the field that has a similar interest to you that can join you or you can join on your STEM journey. It's a lot of fun when you have a bunch of people who are able to work together and share those ideas and collaborate. And, STEM fields are difficult. Getting appropriate access is challenging, but with allies, the work becomes a lot easier. And I can even remember, my first project in high school, I actually, roped in a friend from a deaf school, and we did a science project together. And that's kind of what really sparked my interest in the STEM fields. Same with my work at the university. If I never worked with anyone else, if I just, stayed in my bubble, I definitely wouldn't have progressed as much as I have. I owe it to my collaborators and allies.
I think Colin is really on the nose with that. I'm not going to repeat what he said, but I'll just add 2 things. The first is that, yeah, STEM can definitely be a challenge. And when you have barriers, that just increases the challenges you face. And it can become a personal issue to try and figure out, is this worth it? Is this really what I want to do? And if you don't know the answer to that, find out. Contact people. For example, if I had not turned toward the LLE and chatted with people there, about what their everyday job looks like, the good parts of their job, the bad parts of their job. If I hadn't had that to experience and figure out that, oh, that is what I want, I realized that my frustration would be worth it because that is what I want. And then the second thing I wanted to add is that don't be shy of failure. Don't be shy of your struggles. Share them. Let other people know, like, yes, I did struggle with this, or, I just wasn't successful. For example, I will tell anyone who's willing to listen to me that I failed calculus twice, but I finally made it into a PhD program eventually. So at the same time, celebrate your successes. Doesn't matter if it's minor or a major success, it's still something to celebrate. And it gives yourself something to be proud of.
I think the two of you said it beautifully. Beautiful advice. If I could just add to what both of you have said, if you are trying to figure out what you want to do and a field you want to pursue, but you've maybe never seen someone who's looked like you or talks like you or uses the same language as you in that field, it might lead you down a different path, but don't give up. If it's something you want to do, if you're determined to make that happen, go for it. Don't let that stop you. Don't think that you can't make it work because you've never seen it happen before. Because let's say if you're a deaf person, you've never seen a deaf person in that field. If you set your mind to it, you can make it happen. If you have, others, friends, for example, who are going to share this interest with you, that can be on that journey with you, it'll make it all the more fun.
Wonderful. Thank you so much. Thank you, Mandy and Colin and David, for being here and sharing the amazing work that you're doing in quantum science and inspiring us all with the incredible work you're doing, making STEM more accessible. It has been wonderful to have you. I'm so sorry to our audience if we didn't get to your questions, but I know we did get to a few. So thank you again for your amazing answers to those questions. And that is all the time we have. So I'm going to give our panelists a chance to say goodbye. And
Bye, everyone.
Bye, everyone.
Bye.
Hope you enjoyed the show. Have fun with science stuff.
Thank you.
If you're thinking of physics, go ahead and do it.
Great. Well, thank you again so much. Thank you for joining us at MOS at Home, and we will see you next time. Goodbye.